Welcome. Today's presentation is on Gibbs free energy and it's presented by Science Visualized. What's Gibbs free energy? Gibbs free energy represents the total energy in the system. It involves enthalpy, which is energy associated with the heat of a reaction, that's the heat given out or absorbed in the course of the reaction. Entropy, the energy associated with the degree of order or disorder in the system. And then temperature, measured in Kelvin. And when you put all this together, the change in Gibbs free energy equals to change in enthalpy minus temperature times the change in entropy. If the change in enthalpy, delta H, is negative and the change in entropy is negative, so we'll see it will be negative times this negative here, and the whole thing changes, becomes a plus, so it becomes a positive. And now what we have is negative plus a negative. When you add two negatives, you end up with a negative. So the change in Gibbs free energy will be a negative. Next, if the change in delta H is a negative and the change in delta S is a positive, now we have this negative stays, so this remains a negative. So it becomes negative and negative, and that will give you a negative value, a larger negative value. Next scenario, if the change in enthalpy is a positive and the change in entropy is a positive, so this still stays negative, so you end up with a positive minus a positive. Now, depending on which value is larger, if the change in enthalpy is larger, say 5, then minus 4, then the answer becomes a positive. If the change in enthalpy is smaller, it's a smaller positive, say 3, minus a larger positive 4, then that will end up a negative. So it could be either negative or positive, depending on the exact values of delta H and T delta S. Last scenario, if the change in enthalpy is a positive, but the T delta S is a negative, we'll see that this whole value is a negative, then times a negative, and then it changes it becomes a positive. So that becomes a positive. And therefore you end up with a positive plus a negative. If the negative is large, if this is large, then you end up with negative change in Gibbs free energy. If the negative value is smaller, so you end up with something, say 4 plus minus 3, then that becomes plus 1, so it ends up being a positive. So it depends with what the value of T delta S is. So we see that the only time that we can predict that the change in Gibbs free energy is going to be a negative is when the T delta S is a negative. Thank you. Please subscribe.